All right, so what we're going to do is we're going to take the equations of our quadratics and we're going to graph them. So we're going to start with by finding the vertex. All right, the vertex is a really good starting point, and then we're going to use x-intercepts, y-intercepts, and the axis of symmetry to fill out the rest of the graph. Then adding on to that, we'll add in some word problems in the next lesson based on that information. So we have two methods. Completing the square puts it in vertex form. If you can easily complete the square, I highly recommend it because getting the rest of the information is a lot easier in vertex form than in standard form. Okay? So if we can use one equation to get all of our information, let's use it. Okay? So I want to complete the square, so I separate the -9 from the other two terms, and I have to add something in here and subtract the same thing. How do I find that number? Yeah, b divided by 2 squared. Good, okay? So it's going to end up being 4 and 4. Now, when it factors, what does that factor to be? So we're going to have x something squared. What's it going to be? It's plus 2. Good. And then -9 minus 4. Okay. -13. So now that we have it in vertex form, what is my vertex? It's 2. Positive, not positive 13, still -13. We only change the x value. Remember, our formula is x minus h squared plus k.
Oh, okay.
So this one gets a sign change, but this one doesn't.
So it does plus 13. Remains plus 13.
Yes.
If it was x minus.
Yep. We always change the sign on the x value. That's why we have this negative in the formula. That negative says, hey, let's change that sign to the opposite for our x value. And remember with our transformations, if I have a plus 2, that means I'm moving to the left. Okay? So plus on the inside means I'm moving to the left, so I need to go left 2 units. That's why I'm getting -2. Okay? So there's our vertex, -2, -13. Okay? All right? Now, if I've got that leading coefficient, we got to factor that out first. All right, but since I factored out that 2, I have to remember to do something special over here. Multiply it by 2. Okay? All right, so what number is going to go in the box?
1.
b over 2 squared is 1. So both of those get a 1. So we bring down the 2. We factor that to be x what? Squared. Not plus 1. Minus 1. Keep that sign. Okay? And then the right side, what is that going to simplify to?
Minus.
Okay? So we got -1. And then we can see if we've got ax minus h squared plus k, change the first one to a positive, keep the sign on the second one for the negative. What does this 2 do again? It tells us it goes wider or narrower. So if I have a 2, is it going to be wider or narrower? Narrower. Okay? It's called a vertical stretch.
It's bigger than 1, right?
Yep. Bigger than 1. Okay? So that's completing the square. If completing the square is too tedious of a process, because sometimes it just is, all right, we have a backup. All right, we have a formula that's derived from the quadratic formula that we can use in order to solve for the x value of the vertex. Okay, it's actually the formula that gives us the axis of symmetry, but the axis of symmetry always passes through the vertex. So if we know the x value, we have the x value. All right, what is my quadratic formula? Remind me.
Minus b squared minus b minus squared squared 4ac.
Okay, so quadratic formula is magical. Here's why. Go back. That's where we get that from. Okay, that gives us the axis of symmetry. All right. Now, what was this thing?
That was
Discriminant. What did the discriminant tell us?
What's that?
There were solutions. Remember that solutions also refer to x-intercepts, right? So if I know I'm going to have two x-intercepts or one x-intercept, the discriminant tells me that. And then it gives me the x, and the reason the quadratic formula gives us the x-intercepts is because it's based off of, hey, here's where our vertex is, and then this tells us how far away from our axis of symmetry our x-intercepts are going to be. So it tells me where the axis of symmetry is. So I draw a graph, one giant highlighter apparently, okay? And I have a vertex that's here, right? With an axis of symmetry. So I find my vertex. The discriminant will tell me how far to the right, plus, how far to the left, minus, my x-intercepts are. So if I had plus or minus 5 from my axis of symmetry, 5 units to the right, 5 units to the left, and that gives me the x-intercepts of my quadratic. So there's a lot of information packed into this one formula. All right? So now using the axis of symmetry, if I have the x value, I need to know the y value for my coordinate. So if I knew just, hey, I know x is 1. I know my vertex is x equals 1. What could I do with that information and my equation to find the y value? Plug it back in. So that's what it is. We're finding the axis of symmetry, taking that x value, plug it back into the equation, and then solve. Okay? Now again, I recommend completing the square if it's something that can be done easily, but sometimes it's a little bit more of a chore, and so this will work to get us our vertex. But if we can go ahead and get it in vertex form, solving for x-intercepts and y-intercepts is a lot easier just using the same form over and over. Okay? All right, so find the vertex formula, or use the vertex formula to find the vertex of the graph. So we're going to complete the square because this one's, or no, we're going to use the vertex formula because this is the vertex formula. Right? Yeah. We could, but I want to use the vertex formula. Okay? Because it use the vertex formula. All right? So negative b over 2a. What's my a value?
2.
And negative 2. What's my b value? 3. Good. Okay, so I've got negative 3 over 2 times negative 2. So what's the x value of my vertex going to be? 3 over 4. Okay, so 3 over 4 is the x value.
Negative 3 over negative 4.
Which is? Alright, what do I do with that 3/4? Plug it in. So I want to solve for f of 3/4. See if you guys get as tripped up on the fractions as first period did. Right, what do I do first?
Times the whole number.
Square it first. So what is 3/4 squared? 9 over 16. Okay, now what?
So what's that? 3 over 2.
Yeah, so that'll become
6 over
4. Yeah. So negative 2, 9 over 16. Right up here. Alright, so 3 over 2.
Yeah.
Okay.
And shouldn't you times 2 minus 2 by 9 over 16?
Mm-hmm.
So negative 18 over negative 36.
No.
32.
6 over 4, which reduces to 3, right?
Yeah.
I'll make sure it's happened today. Several times.
So you get minus 18.
Nope.
So minus 18.
Which simplifies to
What am I saying? You get it all.
simplifies to
29. That way. Oh, we're tripping, right? That's what.
It happens.
Yeah. Wait. No, wait, you're still right. You wrote it wrong. It's 3. It's a 3.
Oh, the 3!
That's why I'm just like,
Oh,
wait a minute.
see, I told you. I lost my mind.
Sounds
Mm.
confused. Okay,
You're right. I lost my mind. That's a 3. Up here, I wrote it wrong. So we just need to fix this fraction. See? I can lose my mind. It happens. Happen again, won't be the last time. So let's try that again. 9/4. There we go. Okay. Now we're back on track.
Now, do you need
I do.
Which is 4.
No.
to
No.
be
The least common denominator is going to be the least common multiple. It's always going to be a bigger number. So I'm turning this 4 into the 8. So negative 9/8 plus 18/8 minus what? 8/8. Fractions, man. So what do we end up with?
Minus.
And there's my y value.
Fraction. So please explain from the second part. I got
To here?
yes.
Okay. My least common denominator is going to be the 8 because I can turn a 4 into the 8. Like I can turn the 4 into an 8 by multiplying. Okay. So multiply top bottom by 2, that gives me 18/8. And then this is 1/1. So in order to get a denominator of 8, multiply it by 8, 8/8. And then negative 9 plus 18 is 9. Minus 8 is 1. Okay.
So what's the difference?
You good? Alright, so now what we're going to do is we're going to graph. So first we need to determine the end behavior, which means which ways are going to open. Is it going to go up or down? What do I look at to determine whether the graph is going to open up or open down?
the A.
The A value, okay? What specifically about the A value?
What is greater or less?
Yeah, so positive or negative. Positive means it opens up. Negative means it opens down. Okay? So we look at the end behavior. Then we find the vertex. Okay? Either by using vertex formula, completing the square, whatever is going to be the easiest. Find our intercepts. So for our x-intercepts, we want to solve where f of x is 0. We want to set y to 0. To find our y-intercepts, evaluate for when x is 0. Then we can complete the graph using our axis of symmetry, usually with the y-intercept. Okay, so we can look at the y-intercept, use the axis of symmetry. That'll give us another point. Okay? So, this one's pretty easy to do completely the square, so we'll do that. But first, let's identify which way is it going to open. It's going to open up or down. It's going to open up. Why? The leading coefficient is positive.
Oh,
The leading coefficient is positive, so it's going to open up. All right. Now we want to find the vertex. So vertex form is going to be pretty quick. What number goes in the box?
9.
Good. So what does it factor to be? And then on the right side? So where's my vertex?
Plus 3 and 4.
There you go. 3, -4. Okay, so my vertex is at 3, -4. Alright. Next we need to find intercept. So it opens up, we got a vertex at 3, -4. Now we need to find the intercept. So again, I've got it in vertex form already. So I can use either one to find the x-intercepts. What do I have to do? What does f of x have to equal in order to find the x-intercepts? 0. So we're going to set it equal to 0. So your options are either set your original one equal to 0 and then factor, or set set this one equal to 0, this version, and then you can use your square root property. I prefer that one. Okay, now I don't have to factor it. Have to work, all the hard work's already done. Just isolate this. 4. And then what? Square root both sides. Plus or minus 2 x. Why that added that line in there? X minus 3. Okay, so I have 2 equals x minus 3, and I have negative 2 equals x minus 3. So what are my two values of x? This one's 5. What's the other one? Nope. Positive 1. Negative 2 plus 3. So what are my two x-intercepts? 5 what? 5 comma 0 and 1 comma 0. What does the x need to be to find the y-intercept? 0. Okay. So again, I could take either of those and just solve. Okay. Standard form is probably easiest, because then I make it 0 squared minus 6 times 0 plus 5. So where's my y-intercept? What's 0 squared minus 6 times 0 plus 5?
That's 0 squared.
Yeah, 0 squared. 0 squared is 0. 6 times 0 is 0. 5. Standard form is the easiest for the y-intercept. Everything else is just a matter of preference depending on the equation. So I've got all my key features. So let's put it all together. Alright. Where's my vertex? Where's the vertex? Look back in your notes. Where's the vertex? It's 3, what? 3 negative 4. Guys, this is the same equation. We're still on the same one.
That's right.
Okay.
Because remember, it was x
There.
minus 3 squared.
Same equation. Okay? So I got my vertex. What were my x-intercepts?
5, 0, and 1.
Good. Y-intercept?
0.
Good. Now, plot these points. I've got 3, negative 4, 1, 0, and 5, 0. And then I got my y-intercept at 0, 5. Alright? Now, based on my x vertex, where's my axis of symmetry? That x equals 3. Axis of symmetry is at x equals 3. So let's take that axis of symmetry and draw that in there. So we see it. And then what we want to use, by using that symmetry and looking at our y-intercept, we can find its symmetrical point on the other side would be what? If I know I have the point 0, 5, what other point do I have to have over here? 6, 5. I can use that symmetry to fill in that last point, and there's my graph. Yep, by using our symmetry, 6, 5 is also another point on the graph. Domain. Good. Anyone ever gets that question wrong on the exam, I'm going to be mad. That is your freebie right there. Domain of all your polynomials is all real numbers. Range.
Minus 4.
There you go. Now, you have the graphing utility on your calculator, so you can always use that to check your graph. But I still need to be able to see you finding the vertex, finding the x-intercepts, finding the y-intercepts. Okay. Otherwise, what's the point of teaching it if it's just plugging in your calculator, right? But you can use this check.
All the answers
I know. Okay. Now let's talk about discriminant, because we talked about the vertex formula. the axis of symmetry. Talk about the discriminant again. So, if you get a discriminant value that is less than 0, meaning it's negative, how many solutions did we get? Or more specifically, what kind of solutions did we get? We got 2, what? If our discriminant was negative, non-real. 2 non-real solutions. Okay? So if I have 2 non-real solutions, graphically that translates to no x-intercept. Okay? That's why our answers are non-real, because it doesn't intersect the x-axis, and our quadratic formula tells us where our x-intercepts are. If I get one solution, it's 1. If x is 0, I get one real solution, one rational solution, real rational solution. That means that my x-intercept is my vertex. That's the only way you'll get one x-intercept, is if it's the vertex. So when our discriminant is 0, my vertex is on the x-axis. If I get 2 intercepts, x is, my discriminant is greater than 0, that means I have 2 solutions. Either rational or irrational. Doesn't matter. But that gives me my 2 x-intercepts. So your discriminant will tell you the number of x-intercepts you have. If 0, meaning you have non-real solutions, no x. 1. 2 solutions that are real will give you 2 real intercepts. Okay? So we're just going to end up with these last 2 slides with just solving for the discriminant. So what's my formula for the discriminant one more time?
B minus 4AC.
B squared minus 4AC. What's my B value?
1 minus 1.
A value.
Minus 3.
C value. What does that equal?
1 minus 12. 1 minus 10. 1 minus 12.
So if my discriminant is 25, how many x-intercepts do I have? 2. I have 2 x-intercepts. Go ahead and do the other 2 on the next slide. What's my first discriminant? -3. How many intercepts? None. What's my last discriminant? 0. How many intercepts? 1. Easy peasy, right? Okay? So